All right, our goal is to determine the equation of the tangent line to this curve when x is 0. And when we see equation of tangent line, we should always just immediately write y minus y1 equals m times x minus x1. And we know that our x1 is equal to 0 given information. So now we just need to determine y1 and m by using this information up here. So the first thing we can do is determine y1 by plugging x in and seeing what y is. So we get 2 times 0 squared plus y squared minus 0 times y equals 9. So then we get y squared. Okay, so 2 times 0 squared is 0. 0 times y is 0. So we're just left with y squared equals 9. So it turns out that y could actually be plus or minus 3. So we have a point at 0, 3 and a point at 0, negative 3. I think the answer key only shows this one, but there actually are two. And so we should really write an equation for a tangent line of both of these, where x1 is 1 and y1 is equal to 3 and negative 3. So first we have to be able to determine our slope, which comes from taking our derivative of this curve. So I'm just going to go over to a new page and copy this down. So now we need to implicitly differentiate to determine what our dy dx is. So we get 4x, the derivative of 2x squared, plus the derivative of y squared is going to be 2y times y prime minus, we have x times y, which is a product rule. So we have to do the derivative of the first function x, which is just 1, times the second function, plus the first function x times the derivative of the second function, which is y prime. And then that's equal to 0. So now we need to isolate y prime. So we have 4x plus 2y y prime minus y minus x y prime. All I did there was distribute my negative, and that's equal to 0. And what I need to do is I need to isolate y prime. So I need to include all my terms that have y prime in them on one side of the equation, and then factor out that y prime. So I'm going to be left with 2y y prime and xy minus xy prime on one side. So if I factor out that y prime, I get y prime times 2y minus x. On the other side of the equation, I'm going to subtract my 4x over, so I get minus 4x. And I'm also going to add this minus y over, so that's going to be plus y. So then my final y prime is going to be negative 4x plus y divided by 2y minus x. So this determines my slope with my x and my y plugged in. So what I have is I have a x equals 0, y equals 3, and I have x equals 0, y equals negative 3. Those are my 2 points. So if I plug in x equals 0, that's going to give me negative 4 times 0. We'll do plus 3 first, over 2 times 3 minus 0 is going to be 3 over 6, which is equal to 1/2. So my slope when x equals 0 and y equals 3 is going to be 1/2. So now I should go back over here and write my equation y minus 3 equals 1/2 times x minus 0, which you don't have to write x minus 0, you can just write x. Okay. Now let's do it for 0 and negative 3. So if I plug in 0 and negative 3, I'm going to get negative 4 times 0 minus 3 over 2 times negative 3 minus 0. And that's equal to negative 3 over negative 6, which is also equal to 1/2. So our slope there is 1/2 as well. So now we're going to come back here and say y plus 3, because now our y1 is negative 3, so we're going to subtract a negative 3, and then that's going to be equal to 1/2 times x minus 0. So these are our lines, and I'm just going to give you some visual context here to show you what's going on. So what we have here is we have this kind of weird slanted ellipse looking thing if you were to graph this curve. Okay, something like that. And so when we have our point at 0, 3, our point at 0, 3 up here has a slope of 1/2. So we have that tangent line. And then like if I draw this a little bit better, it should be the same. So it really looks more like that. So then when you have your point at 0, 3 and 0, -3, 0, 3 and 0, -3, and you draw the tangent line and the actual curve, the tangent line is parallel because they both have a slope of 1/2. So we just determined that the tangent lines both, both have a slope of 1/2, so they're parallel to each other. Just one of them is at -3 and one of them is at +3. So that's our two tangent lines. You don't have to be able to draw a graph or picture this in the actual problem. You just have to be able to get to this answer with partial credit along the way for determining what your y values are and for doing the implicit differentiation and then isolating your y prime. All of those things could potentially earn you partial credit on a question like this. And then you hopefully arrive at a final equation of tangent lines. But I just want to always provide visual context when I can.